Hi students, we're going to talk a little bit about domain and range today. We're going to look both graphically and algebraically at problems involving domain and range. First off, we've got this semicircle going on here. In terms of my domain, those are the x values this graph shows up on. So we're starting at -8. I'm about to write negative infinity, that's fun. And we're going up to -5. It looks to me like both of those are solid endpoints, so we're going to use square brackets to symbolize that. Just as a reminder, interval notation is a way that we don't have to write this thing out as -8 is less than or equal to x, which is less than or equal to -5. Interval notation lets us be a little bit more efficient. All right, and then the range of this, it looks like that's about 1.4. So we're looking at going from a lowest value of 0 and a highest value of about 1.4. We can also deal with domain and range if we continue off of our graph. So the things that are happening here, in looking at this, it looks like I've got an asymptote at -2. So I'm going to just draw that in. And as I go to the right, it looks like we're going to go to infinity in the x and to infinity in the y. All right, and then on the left side of the graph, we're going down towards infinity, but we're never getting to 2. We have an asymptote there. That means that my domain, so we're starting at 2, and we're going to infinity. In both cases, those are curvy brackets because we can't get to either of those things. And then for range, we are starting at negative infinity. I should put negative there. And we're going to positive infinity because we're starting down below and going off the graph, and we're going above and off the graph as well. Here's an even more fun one. We're going to have some different pieces going on. I've got an asymptote at -1. Looks like I've got another asymptote at 8. And it looks like I've got a horizontal asymptote at 0, and it appears like that one's probably going to come down to 0 as well, so I'm going to make that assumption. All right, so for domain, I'm starting way off my graph. So we've got from negative infinity. We have to use a curvy bracket with that because we can't equal it. And I'm going to go up to -1. There my graph stops. I've got an asymptote. I'm going to use what's called a union symbol, which tells me that I have one piece with another piece that we're going to add to that. And that's going to go from -1. And we're going to go all the way up until we get to the next vertical asymptote, which is at 8. And then we're going to have another union. And my last interval is going to be from 8 to infinity. In terms of dealing with this with inequalities, you'd have to say something like x could be less than -1, or -1 is less than x is less than 8, or x is greater than 8. So we have this weird stuff that's a little bit harder for us to understand using simpler notation, or the newer notation that you guys have been using since hopefully Algebra 2, that makes it a little bit easier for us to write. And then as far as the range goes, this is a little bit easier. We only have one gap, but we're clearly going down from negative infinity up to 0. Oh, but wait. The middle portion of this rational function crosses that asymptote. So we actually do have a value there. We don't actually have a gap. That means we're going from negative infinity down below. I'm never having a hole in this graph. I'm just going to keep going up to infinity. So my range would be all real numbers, which I can write as an interval from negative infinity to infinity. I can write it using the notation of an r with the extra bar for all real numbers, or I could say something like all real numbers in words. Looking at domain in terms of algebra, we have to know something about different families of functions. Domain we know is the set of all x values that are going to cause something to show up on a graph. We also know that we have an issue with square roots, in fact with any radical of an even index, where the inside of this cannot be negative for us to get an answer that we can graph. The way that we find the domain here is then we use that. So if 8 minus x cannot be negative, that means it has to be greater than or equal to 0. In finishing this up, I'm going to add x to both sides, and we get 8 is greater than or equal to x. That's my domain. Those are the numbers that if I plug in here, they'll be okay. Our domain issue dealing with fractions, we can never divide by 0. So when looking here in terms of domain, I'm going to completely ignore the top of this rational function and just take a look at the bottom where we've got x squared minus 3x minus 28 cannot be 0. I'm going to factor this because it looks factorable. And when I do that, I've got x minus 7 and x plus 4 cannot equal 0. That means that x cannot equal 7 and x cannot equal negative 4. My domain could be written as negative infinity to negative 4 in union with negative 4 to 7 in union with 7 to infinity. Or you could say that the domain is all real numbers except x cannot equal 7 or negative 4. We can also combine some of these things. We have a situation here where we have a fraction that not only has something with a variable in the denominator, but also a radical. That's going to give us two kind of situations, but we're going to see that they're really kind of the same thing. So the first piece is that we're going to have x squared minus 5x minus 24 cannot equal 0. That means that the whole bottom would be 0. We can't divide by 0. We then have the issue of x squared minus 5x minus 24 must be greater than or equal to 0 because we can't have the inside of this be negative in order to get something graphing. When we combine these two, you might notice that all that really does is turn the greater than or equal to into just a greater than. So if we were to solve this inequality, we'll get our domain. This is factorable again. We've got x minus 8 and x plus 3. It's got to be greater than 0. And I'm going to use kind of a calculus method to think about this. I'm going to think about this graph where I have a 0 at x equals 8. I've got a 0 at x equals negative 3. This is a parabola, so the shape of this graph will look something like this. If we want this to be above 0, that means that the stuff that's over here works and the stuff that's over here works. Anything between these two would be below the x-axis based on graphing this parabola. This means that our domain could be that x is going to be from negative infinity to negative 3 and from 8 to infinity. It's all the stuff in the middle that we have an issue with.